Happy Wednesday. It's a sad day. It's the last day for a week and a half. Next week is spring break. So no pre-calculus next week. That's very sad. All right. We're going to finish up the second unit and start the third unit. We have to look at variation. So we're told S varies directly as the square of X. S equals 5 when X equals 4. We want to determine the value of S when X is 20. So variation. We're told that S varies directly as the square of X. What that means is that S is proportional to X squared. I'm looking, that's a very bad looking proportional. That's better.
So it's like an infinity, but not connected.
It's actually more like an alpha with longer tails.
Oh my God. Oh boy.
Because that's alpha. The Greek letter alpha is sort of like that.
So it would not be like
I'm getting there.
S equals.
I'm getting
K,
there. I'm getting there.
Constant variation.
I'm getting there.
Oh my God. Holy
Right. So here's what proportional means, right? Because you may also see in applications things like force is proportional to length or something. Right? Restoring force is proportional to the stretch of the spring. What that means S is equal to some constant times X squared. That constant K is called the constant of proportionality. It can only be found via experimentation. Well, in this case, we have the data point to determine it. Because we're told S is equal to 5 when X is equal to 4. All right, this means that 5 is equal to K times 4 squared. This gives us a constant of proportionality equal to 5/16. So that is our relation. S is 5/16 of X squared. Now, what is S when X is 20? Yeah. 20 squared is 400. It was a 4, there'll be 100 over 4, 25, 5 times 25, 125.
Did you multiply S with 20?
No, this is S of 20. Because S is technically a function of X, right? Another way you could write it is also this way. Right, S is being evaluated when X is 20. Same thing.
is the phrase proportional to the, or proportional to the same as?
Yeah.
So you could say y varies directly as the cube root of x. Okay.
Same thing. Right, so again, what this is saying is that y is just proportional to the cube root of x. Directly proportional, not inversely proportional. Right? So y is k times the cube root of x. Determine k, we just go, we know that y is 12 when x is 64. What is the cube root of 64? So k is 3. Right? Y is 3 times the cube root of x. So when x is 1/8, y is 3 times the cube root of an eighth. What is the cube root of an eighth? That might actually be one of the best square roots I've ever drawn.
Oh, it is very nice. 1/2.
That makes y 3/2. Right? Yeah, easy. I is inversely proportional to the square root or the square of t. Right, so inversely proportional would mean that I is proportional to 1/t squared. This means that I is k/t squared for some constant of proportionality k. Right. Inverse square proportionality is actually very common. So common that in physics it's called the inverse square law. Gravity is an inverse square.
Yeah, it affects the orbits of the planets, right? Or the gravitational force of the, so the square of the distance. Yeah.
Force due to gravity is gmm over r squared. G is the universal gravitational constant. M is the mass of the first object. M, the little m, is the mass of the second object. R is the distance between them. Says that every object with mass exerts a gravitational pull on every other object of mass. Nope.
Just a fun fact.
It's really fun in the sense that
Yeah, Kepler was big on that stuff, right?
it means that
Wasn't he the one that?
Kepler wasn't doing gravity. He was looking at orbits.
But it had to do with this.
But he wasn't really cared about gravity.
He
So
was predicting.
Kepler's law is about they're essentially elliptical orbits, and you could come up with the aperion and hyperion. right? Essentially the semi-major, the semi-minor, so the closest point and the farthest point.
Yeah.
That was Kepler.
Okay.
This is Newton's law of gravity. Again, it has an interesting consequence. Little Missy here, who got me sick, is attracting everyone in this room. Right, so she's exerting a gravitational pull on all of you. Actually, on all the desks, too. It's just the Earth is so much more massive, so it overrides her. Right. So while I love that one scene in Family Guy where Brian throws stuff at Peter and just starts to orbit him. That is, while an exaggeration, it is based in physics. There's your little fun tidbit. Electric force is also an inverse square. So is magnetic force. So it's a very common occurrence. So we're told I is 100 when t is 15. What is 15 squared? So K would have to be 22,500. There's our relation. Now, when t is 12, twelve squared, 144. So we have 22,500 over 144. $625/4.
Oh, you wouldn't want us to just punch it in and do a decimal for it?
Nope.
You'd rather we gotta simplify the fraction. Okay.
Now, in this case, it's not going to matter because decimal form 156.25 is also exact.
True, yes.
Right, dividing by 2 would also give you an exact. But things like 6,
Anything with a 3 or
8,
seven.
3. I don't think 8 gives you
Well,
exact.
eight's gonna eventually come out, because, yeah, 8.
5/8. Oh, is that
not- yeah, not-
0.125? 1/8, I think, is 0.125.
125, yeah.
That would
But
work.
anything with a 3 factor,
7
7 factor.
wouldn't work.
Yeah.
5 would, it's 0.2.
Yeah.
Right, so rather than deal with that, I just always leave it in fraction form. It's easier. U varies inversely as the cube root of x, so that means that u k over cube root of x. U is 56, when x is -8. Cube root of -8. That means that k is negative 112. And so our relation is u is negative negative 112 over cube root of x. Now find u when x is 1,000. What is the cube root of 1,000? Huh? Oh dear.
10?
We don't know our decimal bases. That's not good. 1,000 is 10 cubed. So we get negative 112 over 10, which can simplify. Negative 56 over 5. Or negative 11.2. So we've had,
Wait, I'm sorry. Wait a minute. Oh, 1,000. For some reason, I thought it was negative. If it was negative 1,000, then it would end up being a negative 10, and right?
right, then it'd be
Okay.
56 over 5 instead of
Okay.
negative 56 over 5. We've now had direct proportionality and an inverse proportionality. You can have both. This is what's known as joint. Actually, this one isn't a case of both. This is just a case of it varying with respect to two different things, but you can also have it vary directly and inversely, right? So directly with respect to one variable and inversely with respect to another. That's the best proportional symbol I've drawn. So this is saying that z is proportional to x times y. That, of course, means that z is equal to some constant times x times y. Now we're told that z is equal to 3 when x is 4 and y is 6. K would be 3 over 24, which is 1/8. Right? Z is then xy over 8. Congratulations, here's your first look at a multivariate function. Z is a function of x and y. You'll study multivariate functions more in depth in Calc 3.
If Can you determine that x and y are inversely proportional to each other from that? Because they're being multiplied together on
No,
the same side of the equal sign?
x and y are both independent variables. So they don't have to have a relation to each other.
Okay.
They could, but they don't have to. Right? In fact, they would have a relation to each other if z was a fixed value. But then we wouldn't have z as our dependent variable. Right, so typically speaking, independent variable means it doesn't depend on anything. So I would just say that x and y in this case have no relation whatsoever. It's $1 per nanosecond.
Oh. Better make the number?
For me, yes. In case you didn't know, there's a billion nanoseconds in 1 second. And there's 60 seconds in a minute, so you're looking at 60 billion a minute late. I'm about to be a very rich man. Could just not give you a grade until you pay me.
No. I don't know. That's extortion.
No, it actually has a term. I forget what it's called. But colleges withhold your academic records until you're paid in full.
They actually do
Yeah.
that?
If you have any kind of balance, even 1 cent, they'll withhold all of your academic records. So it'll be like you never went to school.
But you still got to.
They withhold your degree until you're paid in full, until they're paid in full.
So you can.
Nope, you don't even get the degree. You don't graduate until you're paid in full. College debt is different. You have a loan. The college is paid. You have to pay the loan back. Right, so you owe the government. Depends on how much you take out. If you take out just enough for tuition, then no.
And once you graduate, then they start.
Depends on the type of loan.
Yeah.
Some loans start accumulating interest immediately. Subsidized doesn't, and subsidized does. And private loans immediately. Oh, and private loans you have to start paying back immediately too.
So if I take a loan from the government, I can't get that if I pay the government.
No, the college is paid in full. If you actually look at your account balance at the college, it's zero. Because you took out a loan to pay the college. Right? It'd be like using a credit card to buy a TV. The store's paid in full. But you owe the credit card. Now that's actually a unprotected loan, so you could default and they can't take the TV from you. Car loan is protected. So if you don't pay your car loan, they come and take the car away from you. Oh yes, all these different types of loans. Private loans also aren't protected by the government. Private loans are not. So if you default on a private loan, they can't come after you. Yeah, they can, but they can't. If you file bankruptcy, it's gone. Government loans aren't. If you file bankruptcy, your government student loans don't go away. They stay with you.
I just thinking that, but I don't want to say.
Oh, man.
Oops. I'm looking at the wrong ones.
You know, this
20.
whole time, I was looking at the second I thought it said z equals x minus y over 8. The little tail on the y looked like a minus sign, and I was going bonkers trying to figure out where that came from.
Congratulations, your debt's just been reappropriated. You know, it was a,
Looks like a minus sign.
no, it doesn't. I mean, clue looks like a Y.
Oh, there you go.
Okay, well, you just got the debt too.
I know you better than that, and I know that's your fancy squiggly Y. Yes.
You think that's fancy? Oh dear.
That makes a lot more sense now.
Right, z is 20 times 9 all over 8. 180 divided by 8. That is divisible by 8.
Yeah. 22.25.
No, it's perfectly divisible by 8.
180? Oh, it isn't.
Oh, no, it's not. No, it's not. I'm thinking of 4. Yeah, it's divisible by 4.
That's right. I shouldn't go to decimals.
$45 halves. Okay, we'll look at one more. P varies jointly as the square of x and the fourth root of y. P would be kx squared fourth root of y. And now we're told that P is 24 when x is 12 and y is 81. Twelve squared, 144. What is the fourth root of 81? 3.
Hint, hint, assume they're going to be integers at this point. I think they're being nice to us.
What 144 times 3? What was it? 452?
Whoops. Wait a minute. Oh, 432.
24 divided by 432. 1/18. You do realize all these worksheets are available on Teams.
Those worksheets that you have right there?
Not the solutions, but all the questions already loaded on Teams, so you could even look at them before class. Just saying.
You don't post like the video
No.
up before class though, right?
How can I if I'm recording it during class?
But don't you have like different videos?
Lecture videos are posted before class.
The YouTube ones, right?
Yeah, they're posted the Friday before we cover them.
Wait, so the ones that we like, so you told us the videos that come with the open math?
They're made available the Friday before we cover it. P is 1/18 x squared times the fourth root of y. Oh, this will be fun. What is the fourth root of 1/16? A half. What's 1200 squared?
14.4. My old modem.
14.4.
Well, 14,400, right?
So be
Oh, it's 144,000?
100. So 12 squared is 144.
Oh, yeah.
100 squared would be 4 zeros. So it's 144 followed by 4 zeros.
1 million.
There you go. Yeah.
So
Now divide that by 2. Well, I mean, you could also just write this.
less than 100,000. Wait, no.
And just multiply the 18 by.
So.
Oh, and then 36, nice. 32.
I just multiplied the 18 by 2 instead of dividing the 144 by.
Wait, what are you doing?
I just put the 2 down the denominator. You said, do we have to do that first? Well, no, I mean, you could technically just multiply 18 by 2 and leave the 1200 squared in the numerator. Either way, that's 40,000. Really all you need to know about variation. Very easy. Like I said, it's also a very common model type.
Um,
It's very common. Questions on variation?
We do one with some negative?
What do you mean with some negatives?
Like, what about it? Something like this where one of the variables is negative and the other is positive?
No, I mean, nothing's going to change, right?
I'm just for practice.
If I can get through exponential functions, I'll come back.
Oh, that's right. You said we had 2 things.
Right. Okay, go away. So we just finished looking at polynomial functions and rational functions. Right. So now we're looking at exponential functions and logarithmic functions, starting with exponential. Let's actually get rid of you so I can. Say positive real number such that b is not equal to 1. Right, so b is a positive real number, so greater than 0, but not equal to 1. The function b to the x is the exponential function base b. In everyday life, we work with base 10. Right? The decimal system is base 10. In mathematics, There's a more commonly used base. So 10 is called the common base. Does anyone happen to know what the most used base in mathematics is? The most used base in mathematics.
B,
I'm gonna guess 2 because of computers.
Who is used in computers? Although I think computers now are up to what, 64-bit?
Oh, God, Adam.
They might actually be up to 128.
base 10,
No. Base E. This is called the natural base. Take me too long to open up a calculator, so let me just find my notes. Wait, is it not in here? There it is. E is about 2.718282. It is an irrational number. Approximately. Here's the actual definition of E.
The 3-line equal sign.
Defined.
Oh,
Or is identical to. Right, then of course we have base 2, the binary for computers. Another common one in computers is base 16, hexadecimal. Domain of exponential function is all real numbers. The range, positive real numbers.
wait, that's for y equals 2 to the x or?
B to the x.
Oh,
For every exponential base. Domain is always all real numbers. Range is always all positive real numbers.
base,
Again, remember, B has to be a positive real number.
Oh,
Otherwise, it's no longer considered to be an exponential function.
oh,
has a horizontal asymptote y equals 0. The only thing that changes with the horizontal asymptote is what end. If b is larger than 1, then it's on the left. And as x gets larger, the function will increase without bound. But as x gets larger in the negative direction, then it approaches 0. If b is less than 1, the horizontal asymptote is on the right side. As x gets larger, your function approaches 0. No vertical asymptote. Has no x-intercept. Has no x-intercept. HA is horizontal asymptote. No, the function has no x-intercept. Now, obviously, if you transform it, right, one of the transformations, it could, but just the general exponential as it is, b to the x never crosses the x-axis, which is obvious if you look at the range. And every exponential base crosses the y-axis at 0, 1. Which makes sense, right? Any non-zero number raised to the 0 power is equal to 1.
Again, if it was to the left, b has to be greater.
B greater than 1.
B greater than 1.
Then your horizontal asymptote is on the left-hand side.
And
Right,
then-
unlike with rationals where it was both sides. Here it's 1. It's a one-sided horizontal asymptote.
Could you draw that graph, please?
We actually are going to be looking at.
B greater than- And then b less than 1.
Then the
Right.
asymptote is on the right-hand side. Right, so the lecture video opens up with an interesting problem. It's actually a very common thought experiment. And why not? Because this is the meme, right? A wealthy Nigerian prince approaches you and says, I will give you $1 million today, or 1 penny today, and I will double it every day for the next 30 days. So I will double what you have in your account every day for the next 30 days. What is your best option?
Doubling a penny.
Just take the penny and double it every day. That's exponential. I think you wind up with $10 million at the end of 30 days. Huh?
For 30 days?
For 30 days, yeah. $5 million. 5 point, just about 5.4. After 30 days. Right now, of course, that means that you don't get the million up front, right? You have to wait 30 days, but that is the power of the exponential. It's called exponential growth. That is actually how most investments work. Also how interest works. sadly, the difference between the two is investments is you're getting paid. Interest is you're paying the bank. And of course, your investments make a lot less than the bank charges you. So on a savings account, you're lucky if you find a bank that pays you 1%. Yeah, if you look at the credit cards, they're 29%. This is why banks have bigger buildings than you do.
Go hang a shingle?
No, you actually can't because you have to have licensing. You have to get licensed by, I forget the department that runs banking.
By everybody in the government. I'm sure.
No, there's a specific federal department that handles banking. I forget who it is though. I think it's a sub-department of the Department of Treasury. There's an actual banking department in the federal government that monitors banks. It's a department for everything. The government's too large, but that's a different course that you can debate that in.
Federal Reserve.
Federal Reserve sounds accurate. Whatever. So we're going to look at 2 to the x. We're going to analyze it and sketch its graph. And I'm just going to skip the part where we compare the graph using a graphing utility. Right? You can just pull out your graphing calculator and graph it yourself. Remains all real numbers. Range. Positive real numbers. F of x will approach 0 as x approaches negative infinity. And f of x increases without bound as x increases without bound. And of course, we know that f of 0 is equal to 1. Say there's 0, 1. That would be the point 1, 2. There's 2, 4. Negative 1, 1/2. Negative 2 1/4. That should be good. So that'd be a sketch of 2 to the x.
Is that f of 0 equals 1?
Yep. What's 2 to the 0? What's 2 to the 0? 1. Right. Any number, any non-zero number raised to the 0 power is 1.
Since that's the y-intercept, isn't it always just gonna be y equals 0? And it'll be like 1 like that?
Well, x equals 0, y equals 1. To the negative x. From our transformations, we should already know what this graph looks like. However, as it looks right now to the negative x, it does not look like an exponential function. Right? Exponential function is b to the x, not b to the negative x.
Or if you write it as 1 over 2 to the x.
That's still not exponential, is it?
I don't know how.
You're saying just 2 is being raised to the x? Still wouldn't be exponential. You have to do one extra step. It's a half raised to the x.
Oh. Which does equal 1 over 2 to the x. It's just not.
Right, but that's not written in the exponential form. So 2 to the negative x is an exponential function of base 1/2. Right? Which means domain, all real numbers, range, positive real numbers, right? But now f of x will approach infinity as x approaches negative infinity. Right? Because essentially what's happening is, as you let x get larger in the negative direction, think of it as now 2 to the x. X gets larger. Right? Because the negative is going to flip it back to base 2. And it will approach 0 as x approaches infinity. And of course, f of 0, still 1. Since it's 2 to the negative x, this is going to be a reflection about the y-axis of 2 to the x. Right? Which all of this analysis confirms. I wish I could do like a mirror, but I can't. Then I'm going to have to redraw this. So that is what 2 to the negative x roughly would look like. And by the way, all the exponentials are going to have the same shape. It's just a matter of how steep does this get? Well, that's based on the power. Or based on whether it's 1/2 or less than 1 or greater than 1. But all exponentials less than 1 are going to look like this. It's just a matter of how steep. Right? So how quickly does it begin to rise? Oh, I'm just picking, right? So 2. So for instance here, if I pick 2, it's 2 to the -2, which is a half squared, which is a quarter. So that's the 0.21 quarter. So that's what I'm doing. When x is 1, it's just a half, right? Then that's 0, 1, -1, 2, -2, 4. So I'm just picking several points just so I can get the general shape to be correct. Compound interest. One of my favorite applications. So let's say we invest $1,000 at 5% interest for 7 years. We calculate how much we have if the interest compounds annually, quarterly, monthly, daily, and then finally continuously. So compound interest you gain interest on the interest, right? So it's basically saying you're reinvesting the interest that you earn. There's a formula, and it is derived in the video, so I'm not going to rederive it here. P naught is the principal, it's the initial investment. R is the interest rate, written as a decimal. N is the number of compounds per year, and T is the number of years it is being invested. Compounding yearly or compounding annually. P of 7. Right, we want 7 years. $1,000 times 1 plus the interest rate's 0.05. What is N? Just 1, right? So it'd be 1,000 times 1.05 to the 7th power. We're going to go 1,000 times 1.05 raised to the 7th power. Since we're dealing with money, we're going to go out to 2 decimal places. $14.07 and 10 cents. So in the 7 years, you would have gained $407.10 in interest. Compounding quarterly. How many compounds do we have in a year? 4.
Oh, I'm sorry, that NT,
Or from.
Yes, NT.
that's N times T?
Yes.
Wow. Oh.
Right, she answered your question? This would be 1,000 times 4.04 over 4 all raised to the 28th power. Right? T is 7, N is 4. N is 4, T is 7. Right? 4 times 7. So 14, 15, and 99 cents. So compounding quarterly, same amount of time, we gained $415.99 in interest, which is more than if it compounds annually, which makes sense, right? Because now it's compounding more times. So there's more opportunity to gain interest on interest earned. Monthly, how many times are we compounding? Right, so N would be 12. I'm not going to keep showing the calculator. You wind up with 14.18 and 4 cents. Compounding daily. What is N? 365? This is actually a trick question.
Well, 365 1/4. We have to count for leap years somehow. Wait, repeat the question, please.
Compounded daily, what is N? How many compounds do you have in a year?
366.
360.
It technically it depends on the year.
Oh, okay.
Oh. So what will we do, like, fiscal year?
Do they just change the formula when it becomes a leap year? The banks all change their, well, I guess they don't because they're doing it.
No.
They're beyond that.
They don't, because it just accumulates, so they just add the interest in every day,
Yeah.
right? So you don't really have a formula where you count long term. Right. Leap years would be 366 days. Every other year would be 365. Technically speaking. Right. You can't use 365.25 because it's actually not exactly 365 1/4. Leap year is every 4 years, except when divisible by 1,000. No, except when divisible by 100. So 2100 will not be a leap year.
Oh, yeah.
Except when divisible by 1,000. Then it is a leap year. So the year 3000 is a leap year. So 2000 was a leap year, but 2100 through, so 2100 won't be, 2200 won't be, 2300 won't be, 2400 won't be, 25. The next leap year that's divisible by 100 will be the year 3000.
Medicine's advancing at a rapid pace.
I don't know where that is in the concept of touch.
Do you plan on living to be at least 1,000 years old? Then you're not going to be alive in the year 3000.
Hey, you never know. It's the way technology is going nowadays.
I wouldn't want to be alive in the year 3000. Let's put it that way.
Day.
For simplicity, we're just going to assume that there's 365 days in every single year, just to make the calculation simple, even though it is not technically correct. Right, because even with 7 years, you have a possibility of having 2 leap years in that. Right, you could have 1 leap year in that period, or you could have 2, depending on when you started. So we're just going to assume that our rotation around the sun is a perfect 365 days. No, I actually did do that. 7 times 365 is 2,555. That is about $1,419.03. Continuous compounding. Here's technically how we do it. We take this formula and we take its limit as n approaches infinity. So we let the number of compounds per year increase to infinity. In order to fully appreciate the value you get, you're going to need calculus. So for continuous compounding, you find that limit is e to the RT, and so there's the continuous compound formula. Yep, e to the RT. Again, to fully appreciate that, you need calculus. So it'd be 1,000 e to the 0.35. This one I will show. To get base E, do not use the approximation of 2.71. There is an e to the x button on your calculator. You use that. And hit enter. Oh, wait, I did 0.32. It should have been 0.35. Or if you're using the calculator I recommend, you can also just type in EXP, parentheses, and then the power. EXP is the command for the exponential function base E. And we get 14.19 and 7 cents. Which didn't add that much. Versus the daily, but continuous compounding, clearly the best option. I'm actually going to make a slight change to this problem. Instead of 6,000, we're going to make it 6,500 because the maximum contribution to an IRA went up this year to 6,500. It was 6,000. Now it's 6,500. Unless you're over the age of 55, then it's 7,500. This is going to show you the power of time in compound interest. Since you outed yourself, it's going to be a little too late to see the full power. You already outed yourself as older than the average
Oh, I
college
thought you
student.
said added. Oh, no, yeah, I know, I'm ancient. I'm older than you, I bet. Sure I am.
I was around when the dinosaurs were roaming the earth.
I'm on the north side of 50.
What do they say? Age is just a number. You're only as old as you feel. I bet I feel older than you.
You probably do. I'm noted for my immaturity and giddiness.
I had a cane. Oh, cane. Still have that cane too. It's a solid wood cane. It's very nice for smacking students. Like, I mean,
Yes.
for pointing things on the board. I would never hit somebody with it. All right, so I'm not going to write any of this down. This is going to be purely on the calculator. Right. So 6,500 is the initial investment. That's going to be our P naught. R is going to be 0.12. I'm going based off of S&P 500. It averages, I think it averages like 11%, something like that. It's averaged 11% over its lifetime per year. I'm just going to go 12% because I easily find funds that average 12% a year. I actually have funds that have averaged 15 or 16% per year over their lifetime. So I'm in very good shape. And easiest way to do it is just compound annually. Just look at it annually. All right, so N will be 1. So our formula, I'm going to do this. P of T is defined to be 6,500 times 1.12 raised to the T. And store that. So we want 5, 10, 20, and 50 years. So let's just say this is a freshman level course. So I'm just going to assume that you start at 18. So I'm going to assume 18 years old. Get one lump sum of $6,500, throw it into a Roth IRA. 50 years would put you at 68, average retirement age. That's how much money you'd have at retirement with just that one lump sum investment. That's not adding anything to it, right? First, we start with 5. So after 5 years, that $6,500 becomes $11,455. After 10 years, again, not touching it, you're not throwing anything else in it. It was just one lump sum of 6,500, and you just forget about it. Let's say you just completely forget you have it. 10 years, you now have $20,188 in the account. Oh, and mind you, Roth IRA is nice because it grows tax-free, meaning the government can't touch it, which is always nice. So you've already paid taxes on the $6,500 you put in, and now they can't tax the growth. 20 years. Your account now has $62,700. After 50 years, your account has $1.8 million. And that is if you don't touch it or add anything to it.
And the interest rate stays the same.
Well, again, I'm going based off of what it averages every year. Right? So yeah, some years you're going to lose money. Like last year I lost money. Some years you're going to gain. But on average, it's about 12% a year. So this just gives you a rough idea of what you can expect. And I have done calculations. This was back when it was still 6,000. If you do the maximum contribution from 18 to retirement, right, that's 6,000 a year until 55, then it's 7,000 a year. It's an extra 1,000. I think the calculation wound up being like 13 or 14 million dollars by retirement, just in your Roth IRA, if you do the maximum amount every year. Now that amount's gone up. You can now deposit 6,500 a year. Right, but I mean, if you only leave it in there for 5 years, you're not gaining a lot. Right, this is the power of time. Let's say you want to work another 10 years. That extra 10 years now gets you an extra $4 million. Now you have about 6 million.
Something I'm willing to do.
And again, that's just one lump sum investment, and you never touch it again. And then something I hear a lot, oh, what if the stock market crashes? If the stock market crashes, we don't have a country anymore, so you got bigger problems to worry about. It will come back. I promise you. Look what happened in 2008. Stock market dropped by what, 50%? Within several years, it quadrupled. God, if I had the money 2020, I would have. I would have easily quadrupled in a year. By the end of 2021, it was back up to where it was pre-pandemic. And then some. That was the perfect time to buy. If I had the money, oh my God, I would have thrown so much into it. Right?
Should have sold your house and made a move.
I'm not a house owner. Can't afford to be in New Jersey. Property taxes alone kill you. But you buy like a little crappy wooden cottage and it's like $200,000 in New Jersey.
Not that bowling house?
Seriously, it's ridiculous.
Late 07.
No, you probably bought it right at the right time.
No. Then, okay, mid 07. I'm talking like a month or two before the bottom fell out. I bought it at just about the all-time worst time you could ever buy a house. Thankfully,
Even now,
it's recovered. in
yeah,
value
everything's back.
in the last 15 years, yes. It's, oh man.
Now it's another really bad time to buy because interest rates are really high.
Yeah.
About the full first-time buyers thing.
And guess what my wife wants to do? She wants to buy a house next year.
But I was reading Christopher's start like the interest rates were supposed.
So where you heard that? I just heard the feds are talking about raising rates, and they're actually going to increase how much they raise. So they're actually going to start really jacking up the interest.
Interest rates on like loans or
Yep.
mortgages?
Everything. There's a base interest rate that all of your loan interest rates are based off of. No, it's to combat inflation.
Oh, but like,
So it's not just homes. Any loan you take out goes off of the Fed base rate. So your credit card interest rates are going to skyrocket because they're variable.
I'm supposed to,
Mortgages, if you're going to get a mortgage, fixed rate. So they can't change it. Oh, yeah, that means, by the way, your student loan interest rates are gonna go up. But if you keep taking them out every year, the interest rate changes. So you're gonna start to see the interest rates on your loans. That's why they're in groups. It's technically separate loans. Not one giant loan.
So,
Like mine, I think I have, my student loan is technically 7. Broken into, I think, 7 groups. Yeah, so the feds are gonna keep raising rates, so it's not going down anytime soon.
cost of living,
Yes,
so then the wage should go up, right?
but then that also raises inflation.
So,
So it's a never ending cycle.
exactly. Hey, color that on this too.
Yeah, it doesn't, does it?
We just really, that's
It's a farce. Minimum wage should be 0.
really.
You're-
what
you're-
determines.
You get paid what you're worth. If you add a lot of value to the company, you should get paid more than someone who adds no value to a company.
Should